Here's a management trick that works for both humans and AI. Don't make the senior engineer write every line of code. Have a junior write the first draft, and let the senior just approve or reject. This exact idea is how we make large language models 2 to 3 times faster with zero quality loss. The problem is simple. LLMs generate one token at a time, and each token depends on the previous one. For a 70 billion parameter model, each step takes about 50 milliseconds. So generating just 4 tokens costs you 200 milliseconds. You can't parallelize this, it's fundamentally sequential. But here's the key insight that makes speculative decoding work. Checking whether 4 tokens are correct takes about the same time as generating just 1 token. Why? Because the large model can process all 4 draft tokens in parallel, like processing a prompt. Generation is sequential, but verification is parallel. So here's how it works. Step 1, a small, fast draft model, say 1 billion parameters, generates K tokens. It's tiny, so each token takes only about 5 milliseconds. Drafting 4 tokens costs just 20 milliseconds total. Step 2, the large target model processes the original input plus all draft tokens in a single forward pass. It verifies each one, is check, paris, check, comma, check. And rejected should be which. All of this in about 55 milliseconds. Step 3, we accept tokens from left to right until the first rejection. So we keep is, paris, comma, 3 accepted tokens, then replace, and with the target model's own token which. We got 4 tokens in 75 milliseconds instead of 200. That's a 2.67x speedup. And here's the magical part, this is not an approximation. The rejection sampling algorithm mathematically guarantees that the output is identical to what the target model would have generated on its own. If the draft model assigns probability 0.3 to a token and the target assigns 0.9, acceptance probability is min of 1, and 0.9 over 0.3, which is 1, always accept. The acceptance rate is everything. For code generation at temperature 0, the draft model guesses right 80 to 90% of the time, giving you 2.5 to 3x speedup. But for creative writing at high temperature, acceptance drops to 30%, and the overhead might make things barely faster or even slower. How do you choose a draft model? Option 1. Use a smaller model from the same family. Llama 3.11b as draft for Llama 3.170b. Similar training data, high acceptance rate. Option 2. Use a heavily quantized version of the same model. A Q2 quantized 70B model at 17 gigabytes is much faster to run than the full 140 gig FP16 version. There's also option 3, Medusa and Eagle. Instead of a separate draft model, you add lightweight prediction heads directly to the target model. One forward pass gives you multiple candidate tokens. These extra heads are tiny, about 1% of model size, and this approach is getting increasingly popular because you don't need to manage 2 separate models. Let's see how to actually use this in practice. With VLLM, it's just a few command line flags. Serve your 70B model, point to the 8B draft, set the number of speculative tokens to 5, and you're done. Same simplicity with LlamaDot and Hugging Face transformers, just a few lines of. But speculative decoding isn't always a win. If you're already batch-saturated serving 64 concurrent users, the draft model competes for GPU resources. High-temperature creative tasks have terrible acceptance rates, and for very short outputs under 20 tokens, the overhead isn't worth it. Know when to use it and when to skip it. To wrap up, speculative decoding gives you 2 to 3x inference speed with mathematically proven identical output. A small model drafts, a large model verifies in parallel. The acceptance rate determines your speedup. Predictable tasks like code benefit most. It's one of the most practical optimizations you can deploy today. If you found this useful, hit subscribe for more AI engineering deep dives.